Hello everybody and welcome to the next section in our ethical hacking course. Now in the previous section we finished with the wireless penetration testing section, and we also before that finished the web penetration testing section. Right now let's see what we can do after we actually exploit the network itself. So we saw in the previous section how we can exploit the network or basically hack a Wi-Fi and get into the local network. Now let's see what we can do once we are in. So this is a special section for a certain attack that probably most of you have heard of. It is one of the most common attacks and one of the most known attacks that there are, and it is called man-in-the-middle attack. Now, the man-in-the-middle attack basically is the same as it sounds. It is someone interfering with the connection between a victim and the router. So, let me just explain to you before I explain the attack itself. We need to learn something about a certain protocol called ARP protocol and ARP packets. Now, that is a very important thing to learn since it is the fundamental of the network discovery, and also it is the fundamental of the man-in-the-middle attack. The understanding the protocol itself will also help you understand the attack. So what is the ARP protocol? Well, ARP protocol basically stands for the ARP resolution protocol, and it is one of the most simple ones since it is only used for discovery of MAC addresses. For example, let's see what's my IF config. So my IP address. So my IP address is 192.168.1.4. Now, let's say for example, I wanted to communicate with the router. I would have to communicate with its MAC address first. So what I would do is I would send an ARP packet in order to discover what the MAC address of the router is. So the packet would would be something like this. Who is 192.168.1.1? Tell 192.168.1.4. And then the router would respond to me with the answer, I am 192.168.1.1 and this is my MAC address. And then the process of communication would continue. Now, on every PC there is something called the ARP table, or basically where you store the MAC addresses of the certain devices that are on your local area network. For example, in order to check which devices you have stored in your ARP tables on your Kali Linux machine, you can just type here ARP -a, and it will show you right here that it only has my router stored, which is normal, since it says right here gateway, the IP address 192.168.1.1, and it gives us its MAC address since it performed the ARP request on it. Now, as we can see right here, I, for example, do not have my main PC right here in my ARP tables, so let's actually let me show you how you can do it. So let me just open my command prompt and find out the IP address of my main PC. So you will see the IP address of my main PC is 192.168.1.5. Now, in order for me to communicate with my main PC, I would have to find out the MAC address of it first. Now, we can do that with the ARP request, and ARP request will automatically be performed if I ping my Windows PC. So ping 192.168.1.5 count, and we can specify a count 3, and it will ping my main PC 3 times. And now you will see if I run ARP -a again, I will have 2 devices right here. As we can see, I also now have 192.168.1.5, and I also have the MAC address of my Windows PC. We got it since the ICMP request or the ping request actually had to perform the ARP request first in order to find out what is the MAC address of my Windows PC in order to send the ping requests. That is a simple idea behind the ARP request. Now there are 2 things about the ARP. There are ARP requests and ARP responses. ARP requests are basically something you send to a router, for example, as I said, who is, and the ARP reply starts with I am, or that IP address is located at that MAC address. So let me just show you. If we open up our Wireshark, we should be able to see some ARP requests flowing around. Maybe you will understand it better. And after that I will also show you the contents of the ARP request in Ascapy, which is a Python library. So let me just open first this. And we can filter out ARP at the beginning. So let us just wait for some, or we do not need to wait, let us just ping something. Or no, I need to open a new terminal, since this is terminal for Wireshark. And let us try to ping 192.168.1.5. It will not give us the ARP responses, since we already have... Oh, never mind. But this is not... Okay, so it did give us the ARP responses, even though we had it in the ARP tables. We can have it right here. Let us just close this. This is enough. You can see that the simple concept of the ARP protocol is this. So we send to the broadcast MAC address, so to everyone, we send the question, who has 192.168.1.4? Tell 192.168.1.5. Or basically, let me just check this. This is reversed, so 192.168.1.5 is my Windows PC, and .4 is our Kali Linux machine. So, okay. So this request right here was performed by our Windows machine. As we can see, who has, and then the IP address of our Kali Linux machine, and tell the IP address of our Windows 10 machine. So this was a packet that was sent by our Windows 10 machine to the broadcast address, so everyone on the local area network received this packet, and the one that know the MAC address of the Kali Linux machine will respond. And the response comes from basically us. It can also come from the router, as we can see right here. 192.168.1.4 is at this MAC address, and this is an ARP response. This is the same thing, just reversed. So here we are asking, as a Kali Linux machine, we are asking who is the Windows 10, and here is the reply, Windows 10 is at this MAC address. So those are just basic concept of the ARP requests and ARP replies. So we will just close this, quit without saving. Okay, and now let me show you something else. Let me just enlarge this, so we zoom it in. And if you type here Scapy in your Kali Linux, it will open up something, some kind of a Python library. Basically, we will cover it later on. For now on, just type here ls and then ARP, and you will see the contents of the ARP packet. Now, you do not care about most of these, or actually you care about around half of these. So the OP right here stands for either request or reply. Number 1 will be set to request and number 2 will be set to reply. You can see that in the ARP packet there is specified the source IP field and the IP field of the destination. So basically source IP field would be our IP address, and the IP field for the destination would be the target's IP address. So let's say I want to perform an ARP packet that asks for the IP field, or that asks for the MAC address of our router. I would specify my MAC address right here, and I will specify the router's IP address right here in the IP destination address. We also need to specify our MAC address and the destination MAC address which we will be receiving. So we specify our MAC address so that we can get the reply, and in the destination MAC address we will get the answer of what MAC address is stored at that IP address that we are searching for. So that is basically the simple concept of the ARP protocol. Now you might be asking, let me just close this, you might be asking, why am I showing you all of this? Well, it is the, as I said, it is the fundamental of the man-in-the-middle attack, as all man-in-the-middle attacks basically start with the ARP spoofing. And what is ARP spoofing I will talk about in the next lecture. I just wanted to give you a brief overview of what ARP protocol is. If you want to, you can search a little bit more about it and read on it. It's really not that hard to understand it, especially once we run this attack in practical. You will understand it even more. So let me just finish the tutorial right here, and in the next one I will in theory explain what the attack will be that we will perform, which is the man in the middle attack. So I hope I see you there, and take care. Bye.